Hello, everybody, and welcome to our fifth series of webinar this year about HP Robots Otto. This will be the final one for this year at least. Maybe next year we will repeat it and add new stuff that we're working on. As you can see, and probably many of you already know, we will be talking about competitions and games with Otto. Now, this involves multiple things, including the educational materials that we have, the lessons, but like how everything converged in this webinar from the previous four ones, which I invite you to watch if you haven't. Nevertheless, I will be mentioning and explaining everything, so don't worry, like you don't need to really watch the other four ones to understand what is going to happen now. But we will be converging everything that we have been talking in this universe of Otto, HP Robots Otto. So welcome everybody. As I mentioned before, if you have any questions, you can write them in the chat anytime. We will have still a section for the questions in the middle, different from the first webinar that we did it at the end. So we have questions in the middle, and at the end, of course, we also can come back to you guys. It is intended to be very interactive. You're free to participate. If there's no questions, then we will continue. So agenda today. This is the intro welcome. My name is Camilo. I'm the tech designer of HP Robots Otto at Moravia Consulting. And today we will then talk about the robotics competitions related to Otto, some work that we have been doing in collaboration with WRO, the World Robotics Organization, Olympian, sorry, that it has like, if not the most important robotics competition for schools in the world, and we have been participating more on the sideways. So I will be telling you a little bit of the experience we have with that and what plans we have that include this. The third one is one of our new games, one of our favorites. It's football soccer. As you can see in the photo, you will see we have all the setup here that we created completely with 3D printing and parts of Otto. Including the controls. As you can see there, I will show you how they work inside, how we managed to do the connection between that and so on, and what plans we have related to that. That's the break then for the Q&A. We have the game consoles that we also explored a little bit in the last webinar, but we will review them more in depth and we will do a little bit of bytecoding. I have other Ottos with certain cool aspects that we haven't shown anywhere. So you will have also a little bit of first side of things that nobody else knows. And yeah, so welcome everybody, and let's begin. So this, as I was saying, is where we mix everything now. Finally, everything comes into the most important thing about Otto, which is the learning component. Otherwise, it's just a toy. So in the first webinar, we kind of like did a general view of everything. Then we zoom in into the code part, which is related to the web apps. We have the block coding, the Scratch, things that are very common nowadays with programmable robots. We didn't show the building, but the construction is very simple. There's the manuals online, that's the connect part with the electronics. Maybe that one we didn't go in depth in any of the webinars, but we will mention it a little bit, and maybe we could do a bonus later of that part if somebody is interested in to know more about the like construction and connecting things. The Create was our third webinar. If you remember, we have our special guest from Makers Empire. So like we show this app that we have in partnership with them that allows to anybody to 3D design and print things. And now that we have the parts for Otto, then everybody can simply create those things. And then everything converts in what we call like the real robotics. Like this is like very unique about Otto is that you have these three components and then they merge into that. And the way we are merging in is with these games. So these games is like the next step. Okay, why do we want to build all of this and how to make the learning more fun? So it's like the extra step from all connecting these three things that constitutes like a real robotics. Like if you really want to like learn about inventing robots, these components are very important, and then then you can apply it on anything else. So, well, before I go into the tournament, now that we were talking about the educational part, you can have more information in our page if you go to the Edu Zone. So you have all the lessons, which I invite you to check it out. You only need to sign up; they are for free, and you have all the materials there, the teacher guide, the presentation, the worksheets. They are very nicely written for anybody to jump in and start to learn robotics. Now, this is more on the teacher side. So another new thing we have now is like we have new materials that are come in the form of ebooks that also are books that can be purchased with our partnership with Binary Logic and McGraw Hill. But thanks to this, we can offer them for free. So like with the robot, we include these samples of the actual physical books. They are more focused on the student side of things and more gamified in that sense, or like more for the appropriate age. So that's why we include them in this webinar, because it's kind of like learning, but at the same time it's fun. And it's very specific, easily explained. There are characters that guide the children into every step along the way. This one is more focused on programming, but yeah, like that's the part that it requires more like understanding, because it's about learning how to code. So all the interface, this one is with word blocks. There's also a couple of ones that include the icon blocks. If I go over here, yeah, the interface with icon blocks, which is like our icebreaker of coding, as we call. And yeah, so if any of you are interested, for everybody that stays until the end, we will send them a free copy. Or usually you have to buy the robot to get them for free, but like to participate with this webinar, we were free to share this information if you're interested. So a little parenthesis there. There will be more content like this coming soon. We are working in more activities, and what we are going to show, we will document somehow and appear in this page. And we will also have a new revamp of this page where we will have more information, where you could also submit your own ideas or lessons that you would like to share with the rest of the community and more stuff. Coming back to the presentation, then the tournament. So like it's very common. It was one of the things that I personally neglected at the beginning, like the tournaments. With Otto DIY, we already did that a lot, especially in pandemic times, where we were doing dance competitions, walking competitions, or like just sprints. It was with the biped one, walking, which was very limited, and that's why I was a little bit hesitant at the beginning, because didn't have line sensors. We only have the ultrasonic, and it was very limited for what you could program. Now that we have HP Robots Otto with multiple sensors, multiple expansions, and a whole ecosystem of apps that are easily to use, then it's more than a perfect time. And we have been slowly getting into that topic, and the best way we got into it is with the WRO. This is a topic we started last year when we went to present the team to Turkey, the finals, and last year, and we had a stand, and it created a lot of hype, a lot of interest for not only for the students but the teachers. As a robot that not will compete with other robots like what you see there, Lego based or other similar robots, but like, okay, what if it's a good robot for preparation for the finals? Because the WRO, it's already another level of what, like, I would say is required for somebody to know about. The kids that participate there already know a lot about programming, already know a lot about robots. So why don't we lower the barrier with Otto? That was the question we asked ourselves, and with the different missions they have, the different categories, we are slowly having conversations on how to go there. The first initiative was, well, we are having a community of multiple leaders around the world, in Dominican Republic, in Ecuador, in Africa, here in the Czech Republic, to slowly pilot these ideas we have of the tournament. And the first and the most important thing to have is the map. And this is what we came up with. We have it here. We showed it in the previous webinar a little bit, but we will go more in depth now. Like this map, in the observations we have from the WRO, it was like, okay, you need to have a lot of missions, and most of them are line based. Okay, so we need to have the black lines. Some of them are like moving stuff from one place to another. Okay, then there's a separate category of sumo, and that's in a separate map. So we were like, okay, let's make it more convenient, everything in one place, and let's see if it works. And we come up with this very simple map that allows to do those 3 missions, and you could even use it for more stuff. We already demoed it. This one was heavily used in Germany finals this year of the WRO, which we got also a lot of feedback. And yeah, like I will show you a little bit of how it's used. So first we have the sumo. The sumo, it's just a ring. This time we did it white, following what the WRO are using with the colors. Even though Otto doesn't have a color sensor, the line sensors can still detect some variations in the color, which is a little bit more tricky, and sometimes it might be not that precise, but you can still do it, maybe with more area. So we were also experimenting a little bit with that. And this can be either remote control or automatic. In the previous webinar, we did more stuff. These ones are programmed for that. You can have different strategies, as we talked with our guest in the last webinar with Ivan. He's one of our leaders of this initiative to try to create our own tournament, which now we're thinking some ideas, call it Otto Olympics, and include all of these activities. So this one is very nice. The advantage with Otto is that you have all these accessories that you can 3D print, and it becomes more than just a coding challenge, but a creative challenge of, okay, not only the coding is important to push the other competitor, but what attachment will be better for certain strategies to have more effective push, as you call it. So it can become also like an interesting creative activity. This other category is like a little bit more advanced, but it's like, that's why we have A, B, C, D. It's kind of like you need to have maybe different challenges of moving objects from one place to another, or just moving the robot from one place to another. Automatic or pre-program, or with remote control wouldn't be much of a challenge, but like more on this, okay, can we use it with the sensors, or can we like program it just with the placement similar to in a grid? This is a good example of an object you place in certain position. The robot is programmed and calibrated so like it can take the object and slowly get it into placement, which is basically what is done in the tournaments. Of course, it can be more accurate. You can iterate more, and then with multiple robots at the same time, simple activities that anybody that doesn't have experience can jump into it. The third one, which we were intending with this map, was also a football. If you see, like the size could fit into a football, but then we realized, okay, why don't we make it a separate? But before I go into that, I will move this map here. I will show the third one first, which is like you can also do just a simple line race. So we have this perimeter here, have the sensors of this robot, and you could put maybe place some objects that the robot will take, or you can just, okay, who is faster into go around the circuit, like, and it's a lot of calibration, a lot of like checking the parameters of the robot. You could also have different types of code that follow the line. And this one is just moving into one, but you could also take the robot and put it in the center, and then it also follows the circle. Now, because we have these things here, this one, it shows a very good example of when the robot is not programmed to take into account intersections. So that also becomes a code challenge itself. So you could say still it's a 3-in-1, even though it was mostly intended for the football around, but you can also just use it as a testing to check that the robot is properly calibrated, or you have the proper speed, and even have multiple robots at the same time. And here you can grab some objects and you can move them around with different attachments. And this one is just a normal printed map, which we are gonna put in the website for everybody to download and print on their own. Now I suggest to use some materials that are less consuming, and that I connected to one of the things that we developed, because these maps tends to be folded, tends to be rolled, right? And then with the time, you kind of like need to print it again. So then what we come out with is like, okay, with 3D printing, we can make our own maps and we can make them in a puzzle so that you are not fixed with one track, but you, every time you are free to change to different tracks. So we have this kind of like prints that now we optimize. This we also show, I think, in the second webinar, but they were like clipping the different color. We are not using a multi extruder printer. This is a single extruder printer, but we just change the color. And that allows us to have perfect adhesion of the two filaments. And now that we haven't halved the thickness with more optimized infill here, like it uses very, very little material. I think it's cheaper to do this than to go into a print house and ask for the paper print full color. So, and it becomes reusable. Like you can easily pack it, move it around. You can create different turns. We will have multiple intersections, and this will become like a game of itself. Like just to build the track, it becomes already an interesting activity. We will try with the same guy here, and you will see how it works. Yeah. So this one is actually quite tricky. It's doing the zigzags, but yeah, with a little bit of programming, Otto can do it, no problem. We will be printing a lot of them just to go around the office, for example. Or you could print two in parallel, for example, and then make a race of two, like one of those remote control cars that have like metal tracks, and you just press the button to go who goes faster. So you could do the same. Yeah. So it's not replacing the map that we design, even though, I mean, you could if you prefer, but it's like an additional tool that you can use with the help of 3D printing. We are like really squeezing as much the potential that Otto has in the creative side that many people are not aware of to do this kind of things. So yeah, now one of the funny parts is the football. So in the football, we created a similar concept, the same tiles, but of course without the line marks. Now we have been including some like white areas that also in the final version, like it could represent the exact way that the football is done, or maybe for a different sport or something totally different. And maybe these things could be reused also for the line map. So it will be very interesting to have like a combination of the two things, and you have now a multi-purpose set of puzzles to create different games. Not only the football, not only the line maps. Or maybe in one side you can have one and the other one, and the side you can have the other. So this one is pretty cool. Additionally to that, we are using the starter kits already modified with different decorations. But apart from that, this is the stock of the Otto. Now, you will find something interesting is that we are doing a remote control here. My colleague Patrick will help me here to have a fun game. And yeah, so we have just the normal buttons that we include in the Interact. And they are having a what is called an ESP Now communication, which is similar to Wi-Fi, but it's our own protocol that includes it in the PCB of Otto. It's not Bluetooth. And you could see that I didn't have to do any connection or anything. So yeah, are you ready? So yeah. Gonna let me in. So here a little bit fast. Yeah. has the same snap mechanisms as the Otto. You see the PCB of Otto. You are not hitting here or doing anything different. Yeah, a little bit of. Here are the 4 buttons. We also could do it with the encoder, for example, or with other interfaces, but this is the way. This might be even an independent product if it generates a lot of interest. Now we can also even combine like with multiple press or whole press, so you can make use more of the buttons. So for example here, have this Mecanum Otto, as we call. It's using the Mecanum wheels. I have the same control here, but this one, because it has more movements, I needed to have more buttons. Let me see. Here. All right. So it has the normal forward and backward movement, move to the right and to the left, like in a planar way, right? But then because I didn't have more buttons, how can I make it do like this? So then I can do combinations of buttons. So I can do forward, like the up arrow and the left arrow at the same time, and I can rotate like this, or this I can rotate like this, or in diagonal. So you can multiply the combinations of the buttons so like you don't have to have like a huge amount of like components there connected. So yeah, this is another good example of how to modify Otto as well with using the exact same motors. I can show you. Actually, these wheels were quite big. Like ideally, I would prefer to use smaller Mecanum wheels, which are also available in market. So like we could have the same size of the robot instead of like this expanded. But we have this new model that kind of also is the same as the remote control. So we try to follow the same modularity. This wall was also 3D printed, but this was just a model from online. It's like a puzzle. So a lot of fun elements can be incorporated into the field. And yes, until here, then it will be like the first half of the webinar. If you guys have any questions, then you can start to type them in the chat. And if not, then we will continue. So we'll give maybe what, 5 or 10 minutes for people to ask, maybe 5 minutes if nobody asks. These ones are little things that we just print today, little classes. So if you guys are coming to the WRO finals in Singapore, where we will go and have a stand, you will get one for free. Or 2 if you want. I will sit down then and check if there's any question. I see. Hi, Roger, from Japan. Hi, Ivan. Hello. Happy that you like the fidget toys. Do you guys have any questions so far about that? What do you think about the football? What do you think about the line maps? Will you prefer the printed maps or the puzzles? Okay, we have first question here. The control is cool. Is it possible to buy the circuit board with 4 buttons to make it? Possible, yes. We are actually having some like it's not official, but we are quoting with some football clubs this kind of remote controls as solution for that. And yeah, like you can reach out to us and we can make a special deal for this stuff. So it could be just the, well, you also need the battery, of course, like if you want to make it portable, but it's the battery, the circuit board, and the 4 buttons, and we can send you the files for you to 3D print it. But yeah, like maybe we will make it that you can buy just those parts as a small set in a generic box, and then you can make it. I suggest not to limit it with the 4 buttons. So like as you will see later in the game consoles, and we have them with other components, you could also have, for example, the potentiometer. So with the potentiometer, you could adjust the speed of the robot, for example. Or if you have like the accelerometer, so then you won't need any button. You could technically, with the interact expansion, just have the accelerometer and maybe the button that includes there, and do more movements than that. And you could have the same control. Or like if you also just have the phone, you can use the web control app. So that's another option. It's just that with the buttons you get the clicky feeling, and like it's good for these kind of quick games. Now this is like not the main thing. Like the fun part is that you could reprogram everything here. It's not like typical remote control toy, which probably will be cheaper. But like the fun part about this is that you can create different behaviors of how the robot receives the stuff or what messages you send. You could send more than one command with one button, for example, and it becomes like a learning experience how controls work, not just like playing with the control. It's a good way to get people into robotics, because first it's like, oh, I can play football fine. Oh, I can code. Oh, what is that? But I never code in my life. What should I do? And then it becomes like another icebreaker. We like to break the ice into robotics. Okay, we are good of time then. It's half of time. Any more questions? Okay, Roger has one. How does it recognize the road or mark? Is there a color sensor or camera more inside the robot? Also, we have, I will show it here in this camera. So inside the robot, we have our own line sensors here. So we have the 2 motors, right? Just left and right, servo motors for the continuous rotation. We have 2 just infrared sensors. The normal ones are mostly for black and white, but some colors can be will send you a different signal, and you could recognize some of them. But it's not a color sensor itself. Now you could have a third-party sensor connected and have a holder for it. So it's very versatile in that sense that you don't need to do limited with just the line sensors that we include. It's just like for those ones that are they're more common, and these ones are more efficient for line following the color sensor will be. And then it's just like, yeah, like we detect, we're using the analog input here. You have analog or digital. So the digital will send you ones and zeros, and you can adjust it here with a little screwdriver. But the analogs really gives you more precise, analog measurements from 0 to 4,000 something, and usually it marks 4,000 with black, or with white will mark something like 500, and maybe with yellow you have 700. So then you can have a little bit of conditional there and have different interactions with different colors. Now that's something that we are experimenting with. We never advertise that as you can detect multiple colors, because it's very relative, and these sensors are not meant to be for that. That's why there are color sensors for. But for these activities, we will be exploring more of that and seeing what are the real limitations and what can we do and we cannot do with models. For example, we will really see if we can do the contrast between green and white for the football map, because we could reuse those line maps that are for building the football field or something else. And in the future, we imagine like creating full cities that you could plug here, buildings and houses or things, so you can create like a whole city or like a wall of photo around with the 3D printing. The parts are really simple and easy to 3D print. There's no like really nothing complicated for any printers to do it. So we also designed that so that you can have everything just ready out of the box, free to download, and even we are working on something very interesting that I will show you right after this if there's no more questions. And now that we are talking about a little bit of the 3D part and how fun it can be. Okay, so those are the questions. Now to continue, there's another nice new thing that my colleague Patrick just come up with it just in 2 days, but it's really nice, and we were like, okay, we need to show it. We get a little bit of feedback of people. So there was this idea of like a customizer of Otto, a way that you could preview what you want to 3D print, because usually, and with Otto DIY was the same, it was just a bunch of parts and you had to kind of imagine, okay, I need the top from here, I need the middle of here, and maybe it will look like that, or you will print it first and then you will try to see what you wanted to do, which is also nice. I mean, you can like learn by building or be creative on the way. But this is a very nice web app that will allow to not only preview the different modules of Otto being exchanged in different colors, with different attachments, with different decorations, but you could also later use this file. Okay, I want this face, I want this middle, I want this top, I want it with wheels, or I want it with legs, I want it with a different face. Okay, I will just print it, and then it will immediately open the slicers. In this case, we recommend Orca slicers because it's like the most developed now, and it will just like slowly open it. It usually takes a while because this slicer has a lot of things to load, but once it's loaded, it starts to bring all the parts. And because we say, okay, I want to print the wheels only, then it will import them, and of course you need to reorganize them, but we will have some way that automatically it will lay down the parts with the optimal orientation for printing, with all the settings, so like you don't need to know anything about the slicer. You just visualize how you want Otto to be. You click for print, it's ready in the slicer, no matter what 3D printer you have. Send and go for it. Well, of course, with making sure that the printer has the material, the PLA that you want and everything else, but you don't need to worry about like, okay, what resolution to use, perimeters, infill, not, if it's in the right orientation, if I need supports or not. We usually don't design things that require supports. I will say the 99% of things we print don't require support, so that's a very good way to make it easier and don't waste material. So this is also a preview for something new that we haven't showed to anybody. Now for the PPT is almost finished. I will jump then into the consoles. So if you remember from our previous webinar, I'll first move these robots here so we can show it there. I'll leave these clicky guys here. So, well, some of them require a cable because we didn't put the battery, but you can plug them here. So the first iteration we did was the simple OLED kind of display that we use in Emote with buttons to create different games. Now, here we have this Star Wars game, which you might have seen in our social media. So I do have a secret button here on the back because I didn't have a space in the front for the third button to shoot, but it's a very good way to show that you can just figure out other ways to do the same thing. So move up, move down, set the lights. And if for the ones that were in the previous webinar, you saw that we basically just vibe code this in a matter of 10 minutes, these video games with microphones. And we will do a little exercise now. We will create a game for this console just with ChatGPT. This is the other one that now it shows more of the game. So let's start to play all of them. So here is the classic snake one, right? And you can see that this console has actually an encoder, but the encoder has a button, so then you can reuse it. Now this game doesn't use the encoder, but I will show you what I wanted that. Well, we were using it in the menu, so already for browsing the menu is very, very useful. I will automatically use, okay. Now we'll reset for the other one. So you can see that here I can navigate. Some space invaders, kind of. I'm very bad at this. This one is automatic shooting, but you could do it also that it shoots from behind, like I was doing. Yeah, it changes the level, the speed, and so on. And if you have ideas for games, just let us know. We are just incorporating as many as we can. And it becomes a fun activity. This one is like a clicker. So I love to do it with somebody else. And whoever clicks faster. And so itself, all of this, it's a fun building activity. Again, buttons, battery, the same PCB, right? Just with a similar button like the one we use in Otto, so I could swap this to any of the tabs, or I could take it from this one, or the one with the hat, if I could, and or the RGB LED, to have it here. And we also designed one that you could like attach multiple on the side, like connect them, and then you have to pass the cable somehow, but yeah, so that you could expand it. Here's another game. So the classic Arkanoid. Right. This one is one of my favorites. This one was one of the first ones we did. So yeah, and then you can continue making it even more advanced. I will show you later how is the conversation with ChatGPT. The problem's very simple. Create this kind of games with Now, we didn't limit it only to the display, and that's where we started to use the display matrix. So this one you saw last time. This is just classic Tetris, and with the encoder it's very nice because you can rotate the piece. Right? To get that one there. Okay, this one sucks here because then I'll have a problem there in the middle. Oh, let's just drop this one there. You can see that it looks very nice. It took us a couple of iterations to really get it into a way that the lights don't bleed and that it can pass from one to another. You can see a little big gap here. That's because we are using two of the LED matrix that are in the expansion emote kit. So, but we have the possibility to change them without any soldering. So I will show you after. Maybe I lose, right? So I will show you inside how it looks. Again, same PCB. This one doesn't have a battery, but like it can be underneath. And we have the encoder, which uses the 4-pin cable for the encoder part and the 3-pin for the button. Then we have the other button. And you can see how the 8x8 matrix has two connectors. And the idea of the two connectors is so like you can, from the output of one of them, you connect to the in. And then it becomes an 8x16 matrix. And you can continue changing them. Now, it has a limit. that you cannot connect too many, because then if you turn them on in white, full brightness, it will be too much energy for either the battery or the USB, so you might fry something. But 2 is okay. I think 4 will be the limit if you really want to do something that big. But yeah, with 2 is fine. And you might notice that also in the ring that Otto has there's also an extra connector. Now this one we didn't include, but you could also chain here to another one. So you could just solder one of these cables, one of the strings to this output, and you could do multiple rings. Now that one doesn't have much of an application to chain multiple rings, but if you want, you could. We left that part of hacking and doing more games up to the user. I think I didn't finish showing all the games we have here. There's one last here. It's also very fun. This one is kind of like a golf, so I need to control the angle first, and then I just shoot the ball. Here, boom. I didn't do the hole-in-one, but yeah. So now I can aim more here. Yeah. I know here first. Load. Oh, not too much. Oh no. Let's see if I at least now that is that close, I should be able to. So it's quite precise, the encoder, so I need to turn it a lot. Or maybe I can make it bounce. Let's just make it bounce. Yeah, well, if I pass, it gets to another level, and then in the other level there's more obstacles and stuff. Like this. Yeah, so do you guys have any ideas of games? I have one idea of a game that will be easy to do with Vive coding, and we will try it now. But if you have other ideas, let me know. I really want to get it there. There you go. Because I wanted you to see a cool animation. And then yeah, with the obstacle, then oh, I didn't hold it and press. There's no tutorial, so you have to figure out yourself, like all games, retro games. Okay, so I will grab maybe this one that I can flash, and I know that I have the games, and we will move to the screen. I see in the chat something, so let's see if somebody already suggested some games. Noises in the game. Yeah, Walter. Yeah, actually some of them have the noise already, but maybe you cannot hear them. But we are using the buzzer. So actually for one of the games, I'll show you how to include the noises. So one of the good things that already comes with the board is that you have the buzzer, so that you can always in the games have all those beep sounds. You also have, well, you could do the Bluetooth or the communication with other consoles, so that you could have multiplayer games, which is something we want to try for the next one, or I mean for the next month. And what else is you have also an integrated LED, but it's inside though, but that you could also use it for other things. But yeah, then you just connect the other sensors and try different things. So let me see. Let's jump into first ChatGPT. Try ChatGPT first. I will talk about this later at the end. So I think we did it last time, but we did it with a different example. Now we will do it with a game. So the game will be, let's do Flappy Bird, very common. It has a lot of examples online, so we know that the LML will get it. So I want to make a game for an ESP32 in MicroPython. This one is very important. It has to be MicroPython. Well, you can do an Arduino, but then you will have to flash it and it takes more time. MicroPython is faster for iterations. Like you will see, I don't have to wait flashing, I just like save it. MicroPython, and then I will explain ChatGPT what do I have connected and where do I have it connected. Now you don't need to tell where it's connected. It will suggest some connections, but it's good to have that for reference. So we have this very nice diagram that we also have them in the manuals, but we have put together. And basically, depends on what I want to connect. Usually we have some default like plugs or connectors for the components. So for example, the starter kit, the ultrasonic RGB goes in the number 1 connector. And here we have also the GPIO real numbers. So a secret board usually has, the number of connectors. This one has 11, 3 of them have 4 pins, the rest have 3 pins, so 1 signal. But the real number of the actual chip is what it takes, is used in the code. So that's the ones we are gonna use. We're gonna use the ones on the left and on the right, the ones that are labeled outside. So because I have the display, I usually connect it to the 18 and 19. Now I'm not gonna tell ChatGPT where it is, so that you could see where it will suggest it to put it. It usually puts it in the I2C port, which is the number 3. So it will give me this. It will give me these numbers. But one thing that I have to tell ChatGPT is where the buzzer is. So I will tell, okay, I have an OLED display. For OLED display, it usually gets the one we are using, which is the most generic one. So I didn't need to specify the resolution or anything. And button. So I forgot the button. So a button and a buzzer. I am not gonna tell him what the button, but I could tell them in advance. And buzzer for sounds in the pin 25. I think that already makes it a game. So let's see what it will shoot to us. I could be more specific. I could do more stuff, but I prefer for us to have like a base to work with and then continue in the chat. So let's see what it gives us. So first is like showing all the parameters, the GPIO, which is already assuming if it will be pull down or pull up. That we can change later. So it gives us the GPIO 25 for the buzzer. Okay, and then it's suggesting us thinking that we are gonna DIY this, but because we have Otto with already very easy to plug connectors, we don't need to worry about bread bars or power source because we already have it here. Oh, I forgot to say the Flappy Bird game. So it's gonna start suggest me some dodge blocks. Okay, let's see what game it gave me then. I forgot to say the Flappy Bird part, which I can say later. What I really like is that it's not just, okay, I need a code, goodbye. It's very good for learning. And that's why I like of this AI in these cases, is that you start to understand what libraries are used and why. You can ask why, you can ask to comment all the code to understand every line, and it becomes a learning experience rather than just generating something, right? And the fun part is that we're creating a game. Okay, let's just copy the code. Then we go to Tony IDE, which is a generic way to use microcontrollers like the ESP32 base for this. There's also other IDEs you could use. We could also, actually last time I think we used the web code. So the web code one, if you go to word blocks, then we have the generator on the right here, and then you can like actually open the code here. So I could paste the code here and just give it to data, modify the pins and stuff. But I prefer personally to have this one, which can give me if there's something wrong or something. So another thing I like of Tony IDE is that if you see on the left, I can see all the files that I have in the row. And I don't want to destroy the code that I have there, so I could like save as in this MicroPython device, and call it Star Wars, right? And then I'm creating a backup of the code in the robot, or in this case, in the PCB, which is now here on the right, the left, sorry. And then the main code, which is where it's gonna run, is the one where I'm gonna paste all the code that ChatGPT just gave me. Now, I could play it. I will give a quick check. So the button, I will check where I have it connected. So it gave me by default GPIO number 0, which we don't use in Otto. So I have it connected in the number 4, at least the A button. So the 4, and then I go to this beautiful shit, and then the number 4 is the 26 GPIO. So then I change 26. The buzzer is in the 25, that's good. And it's a very simple game. I mean, it's only 44 lines of code. We will play it, and okay. I don't know what it's supposed to do. So it's just moving to left. A box. Okay. Let's be more specific then. Time sleep. So let me check this. What it was this architecture. So button. Yeah. So just a simple game. So I will tell. I want a Flappy. Okay. So now, all right. The button to move up, because it's a simple game that just use a button. I think it will get it much easier. Have the same things, and let's copy all the code. If it finished, have to be careful. Yeah, it didn't finish yet, so we need to finish. Let it like go. You can see that this code is more in depth. It has the functions. It has the different variables. You can see the conditionals here. It has collision in the drawing. All right. This one, I think this one is gonna look much better. So with this one, we can finish. All right. Oh, I already lost. Let's play again. Yeah. Oh, maybe they changed the button. So yeah, I forgot to change the button. 26 again, because it was not reacting to the button. So yeah. Oh, so here I deleted a comma. Let's try it again. Okay. Well, it's jumping. Oh, there you go. There you go. Oh, but here, what can I do there? Okay. Well, then we can iterate further. The button is working. Just like it's giving me walls that you cannot pass. So, well, those are the things that with ChatGPT you will never get right the first time. But yeah, pretty good. It's a good start. I can tell ChatGPT, hey, you made an impossible game. Can you just make the walls less impossible? And then it will fix it. It will fix it for sure. I mean, yeah. And then I can make the walls thinner, or I can directly just learn the code and do it myself. And that will be a great way. The time is running. I mean, it's almost the end of the webinar. I wanted to close up a little with something very cool we started to work on for maybe the future. Now that we are kind of this fun webinar, we did and connected to AI again. In the last webinar, I showed you a little bit of what we were doing with like cultural autos, like Iris Auto and like the Barbarian Auto, and different modifications, or like for example this one with the hat. But yeah, we were trying to see some pop culture things that we could get inspiration to do more cool autos. And of course, what better than Pokemon? And let us know which one we should start with. We started, of course, first generation. It's my generation, so I think the classic will be Pikachu. That one for sure we will do. But if there's any other that you think looks pretty cool from this image, and if you know the name, then let us know. Or later in the community, I think I will post this somewhere. Or once we do the first reel with Pikachu and how we 3D model, how we like, because yeah, like AI can generate very cool inspiration, but then we need to move it into Maker's Empire or some CAD software to really ideate all of these things. And it was not that easy to also make sure that ChatGPT create the good stuff, because if I show you a little bit of the library, it started to go very wild in some parts. Like at the end, now we kind of lose track, and it's just like it mash things together. So it was an interesting experience. It also kind of started to fade away. Some of them are really good. Some of them are just like, okay, a Pokemon with wheels, basically. That was, but yeah, I think it was a good experience. I think this is pretty cool, and I see it as a future tool for children to just bring their wildest imagination to life. Maybe in the future they will have something that it can bring you the 3D part, but that's why we have Maker's Empire. So how do we like put this into Maker's Empire, for example, and with 3D printing, and how do we attach the stuff? Do we use glue? What can we print together? What will need support? What we can put in separate parts? And I already see some of them very easy for doing little stuff. Some of them, of course, are impossible, like Ditto, for example, like those two eyes. Then you will have to take out the ultrasonic sensor, and then you can make it look like it, but then it's something else. But it's very good. I think, yeah, for example, this one is like just the electrode there. Uh, but some of them have quite interesting stuff that we can try. I really like this one. We'll check in the chat very quickly. I mean, we're kind of like passing the time. Okay, grow light. Yes, I also agree, grow light. But the picture looks very real to me, like too complicated to 3D print. But yeah, I will check the questions if I missed some. So we had the one about the noises. Ottoman. Okay. All right. Transformer Otto. That would be a great idea. Yeah, let's try to, if you are around the community and you guys can post some stuff that you generate with ChatGPT, I will give you like what I did was very simple. I just grabbed one of the renders from the website, like for example this one. You could just save the image, you put it there in ChatGPT, and then you tell ChatGPT do a Pokemon mixed with this image of Otto Robot, and boom, something like that already starts to do that. Now you need to refine. Of course, the first one was like with cute eyes as Pokemon are, but there's like, no, I want the ultrasonic sensor, so it looks more like Otto. And then they are like circular eyes, and you more specific, and then slowly getting it to output good stuff that looks more like Otto, but it still is a Pokemon kind of. So it's we could do the same with Transformers. Okay, let's do Optimus Prime with Otto. It could be quite interesting, or with Bumblebee. Any other character from pop culture is welcome. So yeah, this is the end of the webinar at the series. If you guys would like to have more webinars, you will have to request. We will have to see if there's enough demand for that, and maybe we'll continue more stuff. For now, well, we'll be always around the community. You can join our forum, our chat, email us if any question, and we will have a couple of big events we will be visiting. If you are around for Maker Faire Rome in Europe, here in Europe, we will be there. And we will show all of this, and hopefully we will have a bunch of Pokemon also there for people. We will have a lot of clickers and a lot of, we have also the kitchen with the QR code. Maybe we will ideate more stuff for them. We will be in SIMO in Madrid also. We're talking about October. And in November, we're going for the Singapore final. Well, Patrick is going, my colleague here that has been helping to do all of this set up for the webinars. We also have this participation in the EAS, which is this teacher conference in August or September. So we'll have another video similar to all of this, and maybe we will try to compile this fun stuff and all the games, tournaments, AI that we have been doing with Otto that is not very visible now in the website, and we will slowly share it with more people. Right now we are sharing with people that are very engaged with the project, like you guys that are watching us right now, but we will slowly expand it as we see what generates more interest. Now we're kind of like experimenting a little bit with everything and see what resonates more with the needs of the teachers and the kids at the end, the children. So yeah, this is Camilo. Thanks for being, and no worries, there will be a recording of this, a presentation. At the end, you will get it in an email. And if there's more questions, just email us, as I said, or leave us in the chat. It will be available for some time. All right. So see you then. Hoping to see you in one of the events or online in the community. Bye. Have a great day.